Hello and welcome to the latest installment of our web seminar series from Bick Gardner. Today's topic will be elements of a corporate color program. We have a couple presenters today. Greg Schreider, who's business line manager for paint makers and also key account manager. And we also have Ray Roby, who's business line manager for automotive. We are recording this, and the link as well as the presentation materials will be sent out tomorrow morning, so you'll get that. Also, if you have any questions and time permitting, please enter them in the Q&A box located in the bottom right-hand corner of your screen, and time permitting, we'll get to them. If we do run out of time and run over, we'll follow up individually with you. So with that, I've got a lot of great information coming at you. My name is John Kowalski. I'm part of the marketing team here. So with that, let me first turn it over to Mr. Greg Schreider. Greg, all yours, sir.
Thanks, John. Good afternoon, everyone. I'm going to be covering the elements of a corporate color program today, and our goal usually, or always I should say, is to have good color harmony that correlates with the visual acceptance. You see here all the key elements and how they're interconnected, and whenever possible we want to standardize our operations, any reporting, any communications, and make sure that any measurement system that we're using and the tolerances associated with them agree with your visual assessment. So the first element is instrumentation, and we chose multi-angle color effect measurement, because it's widely used in the automotive industry, but we see a lot of growth of effect finishes outside of automotive, like in office furniture, appliances, computers. So all of these elements would also apply to a solid color measurement program where we use 045 or sphere-based color measurement system to control things. So as we know, color and effect go hand in hand, and also we know that things can appear different on a sunny day versus a cloudy day, so under different illumination conditions. So therefore, we had to take that into account in developing the instrumentation to do this. So we have multi-angle color measurement with the traditional color measurement angles of 45-0, I should say, illumination with detection at 15, 25, 45, 75, and 110. We did add an additional angle at -15, or on the other side of the specular component, that is primarily used for controlling colors that have interference pigments. And then we added 3 different illuminations for sparkle, and also the hemisphere dome represents diffuse illumination for a graininess detection. So we're going to have 6 angles of color measurement and 4 camera images taken with every single measurement. So as I said earlier, if you're looking at something under direct illumination or sunny sky, you tend to get that effect pigment activated and it tends to sparkle. If you have a diffuse illumination, you don't get the sparkling effect, but you do get this grainy pattern that we want to be able to quantify. So a few things around sparkle. We know that there's different terminologies that are used out there. Sometimes people talk about micro brightness or diamonds or glints, but primarily sparkle is the primary term that is used. We also know that it's angle dependent. So when you're viewing a particular color, you have to pay attention to where the illumination is and where you're viewing it. We also know that the type of pigment will affect how much sparkle you get. So whether you have a typical aluminum flake, cornflake, or a mica or xerelic are all going to affect the amount of sparkle you get out of that particular color. We know the amount of effect pigment will increase or decrease the effect of sparkle, and certainly the size of the aluminum flake will impact that. For diffuse illumination, there's also, people tend to refer to graininess and texture are interchangeable. Sometimes people call it a structure or texture to it. But here we know that since you have diffuse illumination, the observation angle is not going to be critical. What we do know is you can only observe graininess fairly close up. So sparkle you can see from many feet away, but graininess or coarseness, you need to be pretty close to your sample to actually pick that up and discern differences. Different causes of graininess would certainly be flake type and flake size. Any type of orientation or agglomeration is going to affect your graininess. A little bit about how sparkle and graininess scales came about. In the early 2000s, we partnered with AkzoNobel and Merck, and Akzo set up some visual studies, and what they did is they took a room, they painted it white, and they put a diffuser illumination in the ceiling, so they got really good diffusion of light. And then they took 8 different anchor panels, and so each panel was equally visually different from the next, so that to say panel 2 was exact, and difference between panel 2 and 3 is the same between, say, 5 and 6. And they laid those out, and then they selected actually over 320 colors that were coming from the automotive refinish market. And then they had 7, actually greater than 5, but there's actually 7 trained observers rank each and every color for what they thought was the graininess, and they could rank it as a 2 or a 3 or 2.5 or 4 or 5 or 5.5, whatever. And then they repeated that same task for 3 different spotlight illuminations or direct illuminations for sparkle. All in all, the outcome of that experiment, the coarseness or graininess and what they refer to as glint or sparkle, there's no correlation between the two. So that means you could have a lot of coarseness and very little sparkle, or you could have a little bit of sparkle and no coarseness, but the things were completely independent of each other. What was the outcome of that experiment? That for all colors, all angles, all observations, between 91 and 96% of the time, all observers chose the exact same answer. So if anybody's been in any visual studies, that's off the hook, crazy good. And part of the other outcome was that they could see on average a half a unit, 0.55 to be exact. So that was also a big takeaway and led to, or helped the development, I should say, of tolerances for these particular attributes. What they did say is they wanted more information about sparkle and sparkle intensity. So what we did is we went back to the drawing board and we did some more work on the image analysis, and we were able to come up with a way to also state sparkle area and sparkle intensity. So sparkle area is just simply how many times does that sparkle happen, and then sparkle intensity is when we do detect some sparkle, how intense is that particular flash or on that particular pixel of the camera image. These are 3 different sparkle models. Pretty much this follows very similar to elliptical color measurement, where you have 2 axes that you can vary, and then the overall size of the ellipse is calculated by the tolerance factor. So in the first example, you have basically a 1:2 ratio. Grade factor is always the longer axis, and then you have a tolerance of 1 for your overall pass-fail for that particular ellipse. Same tolerance factor for tolerance grade and grade factor, 1:2, but now your tolerance is double the size. And then the last one on the right is a 1:3 ratio with a 1 unit tolerance for pass-fail, and that is the most popular tolerancing factor used today in the automotive industry. The graininess value is simply a 1-dimensional scale from 0 to 15. If you think back to the 8 different display panels, every half half increment, they could determine a difference, and that relates to the 0 to 15 scale. So 0 would be very fine or no graininess to something that is extremely grainy, where you'd see a very heavy dark light pattern. So why is it important to combine all of these measurements into one? If we took these two samples that we measured for color only on the left, if you looked at all of those color angles, you'd say, I've probably got a pretty good match here. But the reality is these two samples look very, very different from one another. And you can see that because in the 15-degree sparkle difference, you have almost 6 units of sparkle difference. So remember, we can perceive or see a half unit. So this is 12 times the perceptual difference in sparkle at that 15-degree angle. You'd still be able to see the differences in sparkle at 45 and 75. You'd also see a big difference in graininess since you have 3.5 units difference there. All in all, we use this kind of as a guide for color and effect measurements. So we have to remember that all your effect measurement is also included or integrated into the color measurement. So when we see something different for color and we look at the effect values, if it's more or less sparkling at the 15-degree, that tends to tell people to look at pigment type. Make sure you have the same type of pigments in the two different samples. If it's increasing in sparkle area, that tends to say it's a higher pigment load. So look for the mixtures or the ratios of your pigments that are in your particular sample. And if you have increased sparkle intensity, then that tends to say, look at the size of the pigments that you have in there. If we see more sparkling at the 75-degree angle, that tends to tell us that there's some type of orientation issue going on. So then we want to look at the application. Are we comparing similar applications? Is one too wet, too dry? Is there overspray? All of those things will tend to affect the 75-degree sparkle angle. The other thing we want to look at is the instrumentation, how it performs itself. So again, whether you're looking at multi-angle color measurement, 45-0, or a sphere-based system, you want to always check for good short-term repeatability. So this tells you that you can rely on that instrument for a short-term period after you've done a calibration. You want to look at long-term calibration. So this is going to give you reassurance that you maybe don't even need to calibrate every day. Maybe it's every week or every 2 weeks. In some cases, we don't have to calibrate some of our instruments for 90 days. So you can over-calibrate instrumentation, especially color measurement instrumentation. So this is a good metric to look at also. You can see the Bic Mac has excellent long-term repeatability. And then maybe most importantly is that instrumentation stable over a wide temperature range? So temperature is something that we cannot control. Temperature will go up and down in our laboratories, not as much as in the plants and in the production environment, or whether you're using an instrument inside or outside. So this is really, really important to make sure that anything that you see in terms of your measurement differences is actually coming from the samples being different. The last thing we want to look at is how affected is the instrument measurements by operator. And so on the bottom of the Bic Mac, there's 4 pins that can be set at different curvatures, and that is to accommodate the different types of parts that you might have to measure. But you want to have really reliable and repeatable measurements that are operator-based. And if you have that, then you know that you can go to one binding digital standard. And that's going to be really key to having not only your system run well, but also your suppliers and other people that you want to interface with in your wider network of your color control program. So we want to standardize the standards, and anytime, as I said earlier, we want to standardize our workflow or organize our work so that it's done the same way every single time. So we start with digital standards, and the way that they come up with digital standards these days is they take all of their sprayed standards that pass for, you know, no dirt, no fingerprints, all that kind of stuff. They measure them all, and then they take the average of all of those panels, and you can sort all of that data, and then you know which one panel is at the center of that universe. That becomes your certified digital standard, and then you can go ahead and rank all of the other certified standards, your working standards, and your display standards. And you can do that for metallic and effect colors as well as solid colors. And I will say that since the implementation of digital standards, the improvement in this process has really improved to where they're getting more and more certified standards and less of the display standards. So when we organize the standards, we can do that in what we call standard management inside the software. It's a module inside the software, and you can go in and set up how many times you want to measure a standard, how many times you want to have a sample measured. Do you want to calculate the flop index on the fly? What's the delta E you're going to use? Is it going to be a production tolerance, or is it going to be a batch tolerance? And you can do that for color and effect. And then you can organize all of them by what we call color families. And that is an easy way to have that color family share all of those same settings. And that way, when you circulate and send and receive your digital standards, all of this criteria will be locked in with that standard and cannot be changed. So again, you do that for color, effect, and all of the parameters that you want to control. You can turn on certain angles. If you don't want to use all the angles, for instance, if you have a metallic and you don't want to use the -15 because it doesn't have an interference pigment in it, you can turn that off and you won't see that displayed. So again, it's standardizing the workflow. I'm going to hand it over to Ray at this point.
Hello, everyone. Good afternoon. So I'm going to take a few slides and then I'll switch back to Greg. But so basically, the whole idea of why we created the instrument the way that we did and had such good inter-instrument agreement was because customers ask us to be able to do something where they could go to one tolerance and not have to have, like on the left side, you can see a lot of variation. So if I'm a supplier and I have two plants I'm supposed to match, but the two plants are in two different color positions, how am I going to match both of them? I'm not. I'm just going to try to find a place in the middle. And that's not really going to give me the best harmony on either vehicle. So when we use digital standards on the right side, everybody's going to the same target and everybody knows what they need to get to have the best color harmony as possible. So the other thing that's really important is how we measure. So we have in SmartChart an organizer management portion, and basically here you can set up every location that you want to measure. And one important thing about this is that you want to make sure you always measure with the instrument in the same direction. And this is important because it's a directional instrument. So if you say measure with the instrument turned sideways, you're going to get a different answer than if you measure with the instrument straight up and down. And straight up and down is how we prefer to have everyone measure, because that's basically like how you're viewing it when you're outside looking at the vehicle itself. So we've done a lot of work with the software. Next slide, Greg. So this is the newest version of the software that's out. It's pretty intuitive once you get to understand it. You can see what I was talking about, the organizers, there's data analysis, you can also do something called Smart Lab, which we won't talk about today. And then this is what you see when you open Smart Process. So basically, standard management, organizers, data analysis, instrument management, data transfer, and configuration. So the important thing is that everybody kind of has different requirements about how they want their data exported or how they want it to interact with their own system. So we have a compact SQL server that actually works on the C drive. We have a way to export into XML files. We have a way to export into CSV files, and we have a way to do a full SQL server where all the data can go into the same system. And then whoever wants the data to come out in whatever format they like, they can pull it from that system. So this is something that the OEMs are going to, and I think a lot of the suppliers also like. And in my opinion, this is not just for the automotive industry, even though the example we're going to give you, of course, is for automotive, but anybody who has suppliers that have something that needs to match something else for harmony could use this type of, we call it a proactive predictive tool. So basically what we're trying to do is we're trying to get everybody on the same page before all the parts even come together. So before your even initial build, you're going to know that that's going to be a good position. So this is just an example of all the OEM scales that we have developed, and these are all the people that are starting to use data share also. Everybody kind of has a different pass-fail criteria, but basically they are all using the same equation. And if anybody, you know, automotive, non-automotive would ever like to have their own equation, we could totally help you set that up, and we could work with you to get that developed. So this is an example of data share that GM does. Basically, the fascia supplier and the plant share data, and they compare that data before you're even getting anything to the plant. And then if someone has to make a modification, you can share that data again. And we've seen, it's not just GM now that uses it, it's multiple OEMs, but we've seen that this really helps with like initial build. So when the design group comes in to buy off on a new vehicle, a lot of times if we've done this prep work, that becomes maybe an 8 out of 10 on the first buy off instead of maybe a 2 out of 10. So it's very, very helpful. So this is just kind of an example. So here you can see the fender is in the blue and the fascia is in the yellow. And on the 45, 75, and 110, I think I look pretty good. When I get to the 15 and the 25, I'm getting a little bit of separation between the body and the fascia. And this is where a lot of times in the past, because we weren't measuring the 15, you can tell that there's some variation there, and that's not going to look good when you walk around the vehicle. And it also probably would be offensive to the customer who's going to buy that vehicle. And then we have some data analysis. I'll just show it to you. Okay. So in data analysis, you can see there's this yellow and this green dot. So what this does is it takes all the tolerancing that Greg talked about before when you set it up in standard management, and it puts it into this format. And if you have a schematic of your actual vehicle, you can see on the vehicle that there's sorry, it's a little hard for me to see, but on the top one, can you point to the top one, Greg? Yeah. So there you are yellow to the standard, but your harmony is green because you can see the double dots next to it. Can you point to this? There, yeah. So basically, what it comes down to with what would you sell and what would you not sell? Okay, if you don't match to the standard, of course you want to get there, and that's a very important thing. But if it's an initial build and your harmony is good, so like here you see the 2 green dots for both the fender and the fascia, so that means they're matching. That is more important to your customer than matching the standard. But in the end, you want everyone to go to the standard so that you don't have this slight variation. Here's just another example. This is a full body. Many, many points were measured on the car. And this is just to see if everything is within acceptance. So again, we get some more variation on the 15 and the 25, but all in all, this vehicle is pretty clean and it looks pretty good visually. And another thing in Smart Chart that you can see is what we call color harmony. So this blue line is actually the incoming batch panel. And then you can't read it, but the red or the yellow line is the body and the other one's the fascia. And down here you can see a vehicle and where we measured on this vehicle. So if you see like a trend of the batch panel going a different direction than the body, then you know that there's something going on with your batch and maybe you need to change something with the paint itself. If the batch panel stays consistent, then pretty much if you have fluctuations, you need to look at your process and figure out what's going on with that. And next is my favorite plot. No, this is not my favorite. This is my second favorite. So this one shows harmony over time, and you can basically pick 2 different locations on the vehicle or more. And if it was a appliance or something else, you could also do that. But what you want to see is these should be, the yellow line and the blue line should be getting closer. And a lot of these graphs you see, they're actually going either farther apart or staying the same. So now I'm on one side of the master and the other person is on the other side of the master, and this is not good for harmony. Now my favorite part. Here you go. This is called a travel graph, and I think it's really simple because all you need to look at is if the pattern is the same. So this first one that says 15 to 110 is one vehicle. And basically, you're showing the fender to the fascia. And if my pattern looks the same, when I walk around the vehicle, I'm going to think, okay, this looks good. I have good harmony. Now, if I look at the third one, there. Do you see how now on my 15 angle, I'm way far apart for travel? This is not going to look good to me visually. And then if you look at the blue, the B plot down, Chris, that one also is not going to look good because one side I'm yellow and the other place I'm blue. So these are really quick ways to figure out, like, if maybe I have one vehicle that had an issue or something's trending out. I mean, obviously in this example, it ends up coming back in and it's not so bad, but hopefully that makes some sense. Greg, I think it's back to you.
Okay, so one of the things that we emphasized is that we want good color harmony. We want things to match what our visual impression is. So the next few slides are going to be, I set up a camera outside at a given angle to a fender fascia match, and it's a silver, so you're going to see over time how that the angle of illumination is going to change how everything is viewed. And then there's a chroma flare strip that you'll see as the sun moves, it's going to change color. So this just emphasizes that the direction and position of observation matters, just like the direction and position of your measurement matters, and that visually it can be a pretty big impact. So this was from 10 o'clock in the morning to 3 o'clock in the afternoon at 15-minute intervals. And you can see how the effect especially is changing in that silver, how it pops more, and depending upon where you are relevant to the illumination, it's going to appear very different. So just a visual example to kind of tell the rest of the story as far as visual, because I'm going to hand it back over to Ray, and she's going to emphasize how that can be affected even when you're communicating with other people around the world.
Okay, so how does this outdoor evaluation of a complete vehicle affect us? Well, there's different hemispheres, so we could be in the north or the south. Different times of the year, like we always say, you know, do color harmony from 10 a.m. till 2 p.m. This is technically the solar's peak, but then we have to think about things like where we are in the world and what time of year is it. All right, so what does it mean? So if I'm in Munich on June 21st at 12 o'clock p.m. and I look at this vehicle, I'm looking at an incident angle of 61 degrees. So now what does that mean for the instrument? So now I'm looking at approximately the 75-degree angle. But if, next slide, Greg. If I'm in Shanghai, same date, same time, now I'm looking at 110 because my angle of incident is 82 degrees. So very different. And then if I'm in Cape Town, same date, same time, I'm looking at approximately the 45-degree angle. And what does it mean? Okay, so Cape Town, based on the numbers, I think this car is great. I'm in Munich, I'm like, it's okay. And if I'm in Shanghai, I reject it. And this is all based off of the same vehicle, the same time and date, and you're getting 3 different ideas. So kind of what's important here is that, well, first you have to understand what angle you're actually visually seeing. Second, with these digital standards, the most important thing is to go to the digital standard on all angles, not just one angle or another angle, but everything, so that you can get the best harmony possible. The other thing that's really important is depending on the time of year, the sun is at different locations. So normally color harmony might be done in June. So in June, my angle of incidence is 61. So I'm looking at an angle of 75 or 110. So now I get bought off in this color position on June 21st. Okay, now it's September when I do my first build. Now I'm looking at an angle of 45. So potentially I could have the exact same vehicle under the exact same technically conditions, and have a different visual assessment. And if we're not looking at all the angles, we're going to have a different outcome. And then this one example says December 21st. Now we're looking at the 45 or the 75. So it's really important that you pay attention to where the sun is and how everything is like working around you. And then when you measure that, you look at all the angles and not just one. The other thing that's really important is the size of the observer. So if I'm standing next to some guy from Ford or whatever, and he's 6 foot tall and I'm only like 5'8", I'm standing on my tippy toes trying to make sure that I can see exactly the same angle that he's seeing. And the other thing that's important is like you shouldn't have like, I know a lot of times when people do color harmony, they want to spread out around the vehicle in like a semicircle. This is also very bad because you're all looking at different angles. And next slide, Greg. So before we talk specifically about that, we're going to talk about this. So when we look at vertical panels, if it's flat, you're looking at approximately the 75, but we know that most vehicles are not flat. So now if it's curved, you're looking at approximately the 25. So this again is also very important because you have to think about the angle that you're looking at. I know most of the OEMs at this point are trying to make sure that all the panel to panel matches are flat. And that's because of this phenomena. So another important thing is when you look at horizontal surfaces, if the sun is behind you, you're looking at the 75 or the 110. But if the sun's in front of you, you're looking at the 15 or even the -15. So just things to keep in mind when you're looking at color. All right, so we talked about all these things: time of day, location in the world, the time of year, the size of the person. The other thing I did not say, but I will say now, if you're a smaller person, you should be closer to the vehicle than if you're a taller person. And this is also important. And also, like I said, like you want to be standing in kind of the same line as the other person, not like off to the side. And then the other thing is the vertical panels. You can have different evaluations based on if they're curved or flat. Horizontal panels, depending on where the sun is, above you or behind you or in front of you. And then, like I talked about, the orientation of the add-on parts. Greg, you want to wrap it up?
Sure. So as we kind of started with, program success really comes down to communications, like many things in life. And if we're communicating the intent up front well, and we set up our digital standards well, the intent is there, then it's the implementation of not only the measurement routines, where you measure, how you measure, the orientation of the instrument, which is all kind of organized in the workflow in the organizer files, and then use the software with the intent to share the data. Again, communicating where you are, even if you're not in a good place on color match, you can get help, you can get direction, and you can get things on standard or on color faster. And then to the whole visual analysis, this is really a big and critical thing, because when somebody makes a color call or makes a color comment, you should see that in the data. All the testing that's been done, we know that the data correlates to visual evaluation. Maybe the tolerance is set too loose, or maybe it's too tight. You can work on things like that. But if somebody makes a visual judgment, you should see it in the data. And ultimately, we want to drive programs with data, more with data and less with opinions. But it is important to integrate the visual assessment into any color program. And if you have the same type of program set up for, say, appliance manufacturers, you should understand when you view that appliance, is it going to be in a showroom? Is it in the plant? Is it in a laboratory? Where's the lighting? How is it set up? What angles am I looking at? And can I get good correlation with my visual assessment and then correlate that to the measurement data? And then you can really drive your decisions to reporting that can just basically tell you if the process is running to standard and in control through the green, yellow light process in the software.
And
with
just
that,
a comment, just a comment from my perspective. I know we talked about automotive. I mean, that's because that's what I kind of do. But these things work for everybody. It's the same concept. You want everything to look the same and match no matter what industry you're in. So I think it's really important just to understand the concepts that we've given, and hopefully that will help you. And obviously, from Bit Gardner's perspective, we can always help you develop a good way to use measurement to your advantage.
Great. Thank you, Ray. Thank you, Greg. Great information here. Very appreciative of your insight and your knowledge sharing. So thank you. If anyone has questions, please log them in the Q&A box located in the bottom right-hand corner of your screen. We have a few minutes left here. There is one question here I've been wondering. If a customer's not, or if someone's using the same instrument, one instrument, their customer's using another, can they still use digital standards?
The software is not set up to allow digital standards to be shared amongst instruments that are not the same.
Okay.
The work that has been done to get inter-instrument agreement to the point where you can use standards, we've run the test, and extra instrument agreement to, say, another manufacturer is really not possible. And part of that is because the optical benches that are used are different, and nobody else has implemented sparkle and graininess. So those are unique elements that are, or attributes that are measured, and they are part of your color measurement. So what our intent was is to give you that integral color measurement that includes sparkle and graininess in the color curve, if you will, but then extrapolate what the effect is actually, what it looks like under direct illumination and what it looks like under diffuse illumination.
Okay, good, thank you. If, while people are thinking about questions or hopefully entering them in, Greg and Ray, are there common questions you guys get when you're talking with customers who either are interested in starting a color program, or maybe they have parts and pieces, but just need some help kind of getting to the next level and everything aligned? Are there frequent questions that you guys commonly get when entering, this type of program?
I mean, I think the biggest thing that we see is that you have to get everybody on board. And a lot of times it's the people that do more visual only analysis that sometimes don't like data. But like what we try to convey is that it's not that we're trying to override the visual. We understand that that's super important, but it's really hard, like you saw from what I said, or what my visual part was. You know, depending on the time of year, you're going to see different angles. So you really need the data to correlate to what you see, because if it doesn't, or if you have an angle that's out, then you could look at it at a different time and have a different perspective. So the two correlate together. And a lot of times, like, you know, if the visual people think that maybe the way we set up the equation, not we, but the DIN equation set up, maybe if they think that that's not matching their visual, we can always adjust it. And we work with customers all the time to do this. So don't get scared, in my opinion, you know, to not use digital, because it really helps you. And it gives you a good idea of what your process control is and where your suppliers are relative to you. So I think it's huge. I mean,
Definitely.
I mean, Greg,
yeah, it seems.
You got.
I think I totally agree with that, everything you said, Ray. And I think a program like this is usually born out of a situation that's occurring that you need to solve, and you want to solve it once and for all. And that can be powerful to get management to buy in, to support, because it's going to take resources up front. There's usually some learning that needs to go on up front, and this kind of a color program is really laid out for somebody that's manufacturing a vehicle, or an appliance or a computer or whatever. But these programs can also be implemented internally within, like, a paint company. You just have different things that you focus on in those elements. And one of the keys there is correlating back to the visual, but not so much for harmony, but for what you can see as your formula changes. And when you're dealing with that, especially with a multi-angle instrument with effect measurement, it's really a good idea to use the Bicospectra effect light booth, because that lighting scenario correlates perfectly to the instrument. So you always are looking at the 15 or the -15 or the 45 or the 110. You know exactly what angle you're looking at all the time. You know exactly what sparkle angle you're looking at. So you can get really good correlation to how your color moves while your formula moves. Or how, if you're doing a DOE, what changes in the parameters that you're testing, how does that affect color?
Yeah, definitely a big undertaking, but the benefits of it, you're looking at cost savings, scrap reduction, efficiencies, and that's coming just from my marketing level. I don't know the technical.
I mean, I can tell you from Ford's perspective, we couldn't go to Mexico, and we did a bunch of digital harmonies, and 8 out of 10 of the colors got bought off the first time. And they don't even have that good when they're there on the ground. You know what I mean? So it's hugely important. And Greg and I, we both talked about, we're totally in, and we will help you guys get anything that you need to get done. And we will help you understand all of the systems. It is quite complicated, but I think the benefits way outweigh the complication. And even if you're a supplier, you can use this to go back to your customer and say, hey, I'm on trend. I've been in the same place forever. You moved. This also gives you power too. And that's a lot of the automotive suppliers have said to me since I've been with BIC, they're like, oh, you give us our power back. And I think that's significant also.
And you have that data trail.
And you have the data trail, and you're not chasing a body.
Yeah. Very true. Very true. So attendees, people on, participating in this webinar, are there certain challenges you're facing at your own facility that we can help with? We have about 10 minutes left here, and Yeah, not only Greg and Ray are on the phone, but we have several members from our field team as well. Just it's a lot of expertise, willing and able to help you. Enter any question or any point that you need clarified even further. Just put it in the Q&A box. Should be in the bottom right-hand corner of your screen. Love to be able to help you.
So I think Geraldine and Mike Peters might have some different applications that they could tell us about.
Yeah, a couple members from our field team, Geraldine in the Midwest and Mike Peters up in Canada. Do either of you guys have some specific applications, questions you guys get or benefits to a program like this that you've seen?
I have customers, this is Geraldine Camp, I have customers who are, in transportation, but not automotive, that are currently investigating corporate color programs. They're have very similar problems. They have multiple components, interior and exterior, not only metallic coatings, but plastics and textured. They are attempting to standardize their raw material or their part suppliers' incoming quality, and they're able to do it with the repeatability and reproducibility of BIC instruments. So not only BIC Mac, but Spectre 2 Guide, and then our new instrument that measures also texture color, and 60-degree gloss. So there are programs currently in process that are attempting to implement this type of corporate color program, which would allow them to just reduce the rejections and everybody always to be on the same page.
That sounds good. Thank you, Geraldine.
No,
Mike,
I think what Geraldine said is one. Oh, go ahead, John.
No, go ahead.
I mean, I think what Geraldine said is huge. I mean, it doesn't really matter what industry it is. I mean, everybody wants the same outcome, right? You want your customer to think that you have a good product and be happy with it. And sometimes maybe people don't understand that maybe the color match is off. Like, we did a big study with one of the OEMs, and the problem is that you get the data back from people who actually bought the vehicle, but how many people didn't buy it? That you don't ever know, because they think that if you have bad color harmony between the different components, that it's not a quality product. And you never know that those people walked away. So, I mean, it's a bigger problem than I think any of us even really realize.
Mm-hmm. Yep, definitely. So, keep in mind too, we'll be sending out a link to this recording as well as the presentation that'll come to you tomorrow morning in your email. It'll also have links to future webinars like this that you can register for as well. Also, if you think of a question, after the fact, later tonight or tomorrow or anytime, feel free to respond to that email you get from us in marketing, or feel free to reach out to, any of your local field sales reps from us, and, always there to help solve any challenges and get you running optimally. So with that, I think we'll conclude today's presentation. Just want to thank all the attendees for your time and for listening, and hopefully you learned something. Thank you, Ray. Thank you, Greg, for your time, for your expertise, and sharing and teaching all of us today. So thank you, everyone. Have a great afternoon, and we'll see you at another BIC web seminar. Thank you.